Welcome to Level 1 Mechanics. This video is about acceleration. Acceleration is the rate at which an object changes speed. Okay, an object can increase speed or decrease speed. Both of those situations are acceleration. A decrease in speed, however, is a negative acceleration, and sometimes we call that deceleration. The unit for acceleration is meters per second squared. Some people like to call it meters per second. I prefer meters per second squared because when you look at the abbreviation for the unit, you've got m/s to the -2 or ms to the power of -2. So you can see that they're squared. And in NCA levels 1, 2, and 3, the preferred unit abbreviation is ms-2. So when you're doing your exams, make sure you write it this way. Do not write it with m/s to the power of 2. Formula for acceleration: A equals delta V over T. Okay, delta is this triangle here. It's a Greek letter. Okay, and it's in the shape of a triangle, and it means change in. So delta V means change in speed. A stands for acceleration, and the units, of course, are meters per second squared. Delta V, change in speed. Okay, there's that delta, and that means change in. And the units for speed, of course, are meters per second. T stands for time, and it is in seconds. Alright, let's try a sample problem. A car accelerates from 20 meters per second to its top speed of 44 meters per second in 6 seconds. Calculate the car's acceleration. Okay, so it's increasing speed from 20 to 44 meters per second. So acceleration, that's what we're looking for. Calculate acceleration. Alright, delta V, change in speed, goes from 20 to 44. So we find out the difference between those two. It's an increase in speed, so we're going to have a positive number. So 44 minus 20 is 24 meters per second. T is time, and of course that's taken 6 seconds for it to accelerate. Take our formula, plug our numbers in, and acceleration equals 24 divided by 6. And you should be able to do this in your head. 24 divided by 6 is 4, and our units are going to be meters per second squared. Magic triangle. We did a magic triangle for speed. You can also do a magic triangle for acceleration. Any equation that has 3 variables can be put into this triangle. Alright, because delta V is over delta T, the same thing has to happen in your triangle. And that leaves this bottom corner with acceleration A. So now if we want to solve for change in speed, we want to find out the change in speed. We cover up the delta V, and we can see that delta V equals A times T. Now if we decide we've got a problem that we have to solve time for, cover up the T, and it's T equals delta V over A. Okay, because in the triangle we've got delta V over top of A. Okay, simple. Let's try a practice problem using the magic triangle. The car hits a wall and slows from a speed of 15 meters per second to 0 meters per second. Its acceleration is -60 meters per second squared. Okay, it's negative because it's slowing down. It's decelerating. How long does it take to decelerate? Alright, so let's write down what we know and what we don't know. Alright, we know the acceleration, -60 meters per second squared. We know the change in time. It goes from 15 to 0. So that's a decrease in speed, so it's -15 meters per second. And the time is what we're looking for. So we take our magic triangle, cover up the T, and we can see that T equals delta V over A. Now we take our values and plug them into there. Okay, so acceleration is -60 and change in speed is -15. -15 divided by -60 equals 0.25 seconds, and it's positive. which is good because you should never have a negative time. So a negative divided by a negative will give you a positive. And there's our answer, 0.25 seconds. It took a quarter of a second for this car to stop. And that's how you do it.